All right, guys, let's take a look at example 2 here, and I put this one in here a little bit differently because it involves negatives, and a lot of us have trouble with negative numbers sometimes. So I thought it'd be a good one to do. All right, so let's get right to work here. I'm going to first do it by hand with the formula, and I've already written it down here. So we're supposed to find the distance, and we're just going to go directly to our formula and write d equals big old square root thing. All right, we're going to be really careful with signs here. I'm going to write, okay, -2 minus -3, square it. That's my x values, right? Now we'll do the y's. -1 minus -5, square it. Now this is where a lot of people can make a mistake. If your arithmetic's not really good with your negatives. All right, -2 plus 3, because that's what happens here, is this becomes a 1. So that's actually 1 squared. And over here we got -1 plus 5, which is a 4. And if we square that, we get that. And this is 1 plus 16, so we get the square root of 17. Now that's prime. So we know that can't be simplified anymore. All right, so that would be your answer. Now, let's go take a look at this in terms of a graphing approach and see which one you like better. So I encourage you to use graph paper when you do these problems in Delta Math. And I don't think it's a mistake because it's really quick sometimes. And you're going to find out when we do this coordinate geometry, all these shapes and things, finding perimeters and areas. A lot of times you can graph your way around them and move a little bit faster. Okay, so I've already put these in. There's the C and the D we had earlier that we just put on our paper. We just calculated. Now, what I want to do here is say, okay, now this right here is the hypotenuse that I need to find. And again, with this distance formula, we're always finding hypotenuses. And if you're in the coordinate plane here, if it's a horizontal or a vertical distance, you can just block count. You don't need the formula. All right, so we got to find this distance here. Now there's that 1 squared plus the 4 squared. And square root of 17 comes out of this thing real quick. So if you're following what I just said, the length here is 1. This vertical distance is 4. Using Pythagorean theorem, 1 squared plus 4 squared, 17, square root of that. So I'm saying this is probably a little faster if you're not good with your arithmetic. But anyway, knowing both ways is smart. So hope this helps you, and I will see you guys on midpoint. I think it's our next thing we're going to work on. And